Today we're going to be doing quadratic transformations and vertex form of a quadratic. You will need a calculator if you do not already have one. You may want to grab one. This is a slide from our last lesson, but the most important thing from this is that parent function y equals x squared, and that specifically is the quadratic parent function, because remember we also have a linear parent function that we compare with as well, but now we're going to deal with the quadratic parent function. So we're going to go step by step figuring out what these numbers do to these equations. So graph y equals 1/2 x squared and compare the graph with the graph of y equals x squared, which sometimes it just says the parent quadratic function, so that's definitely something that you need to memorize. So we're going to grab our calculator and we are going to go to y equals, and we are going to graph y equals x squared in our y1, and as long as we are comparing, we are going to leave that parent function in the calculator, and then in y2 we're going to put 1/2 x squared. Then we're going to press graph and we're going to see what happens. So the first one that comes up is my parent function, that's in blue. The second one is going to be my 1/2 x squared, and that's in red. So notice that 1/2 makes the graph wider. So if a, which is the number in front of the x squared, if it is less than 1, the graph is going to be wider. So now we can make a prediction on the bottom when it says compare the graph of y equals 5x squared to the parent function. So I would predict that if a number less than 1, or a fraction, makes the graph wider, I could predict that a number higher than 1 is going to make it more narrow. So let's graph. Go back to y equals. As long as you're comparing, leave that parent function in y1. Now we're going to graph 5x squared. Hit graph. My prediction was more narrow or narrower. There's my parent. And there is my 5x squared. And it did. So if a, the number in front of x squared, is greater than 1, it is going to be narrower. Another thing that can be called is it can be called a vertical stretch, just in case you see that different vocabulary. The one up here would be called a vertical shrink. Would be good to know both of those words. Okay, so you'll notice there is a summary of what we just did at the top of this page. The red line is when a is greater than 1, and then the green line is when a is, and notice this little thing in the green right here, it says it actually says the absolute value of a, because it can't be negative right now. We're not talking about negative numbers. So if it's anywhere from 0 to 1 basically, but not including 0 and 1, it is going to be wider than that parent function. Next thing we're going to look at is what if the number in front of x squared is negative? And what a negative is going to do, this blue line is our parent function here. If we have a negative in front, what that is going to do is flip it over the x-axis. So for instance, if I came over here and I were to change this +5 to a -5, what's going to happen now is that it's not only going to be wider, but it's also going to be turned upside down. Or excuse me, it's going to be more narrow. Didn't mean to say wider. Apologize. Next thing we're going to look at is if we add something to the x squared. So if we add something or subtract something to the end of x squared, so we're going to graph y equals x squared minus 2 and compare it to the parent function. So I'm going to plug that in, x squared minus 2. Press graph. The first one that comes up, even if yours is not colored, the first one's going to be your parent function because you put it first. Then the second one is going to be your one you're comparing. So notice that it shifted from 0, 0, it shifted down 2 units. Notice it had a minus 2. So if you have a plus or a minus, it is going to shift up or down. So if C is negative, meaning a minus, it is going to shift down. Then on the other end of that, if it is positive, it is going to shift up. So notice there's a nice summary at the bottom if you need to look back at that for reference whenever you're working on your homework. Okay, so if we're going to compare, we're going to do the first one in the calculator, then we'll do the second one by hand. So go to y equals. Remember, you only leave the x squared in your graph when you are comparing. So I'm comparing, so I'm going to plug in negative 3x squared plus 3. So the first one's going to be my parent, and then the second one is going to be my transformation. So notice that it shifted up 3. So I could say it shifted up 3. It also, you can tell it got a little bit more narrow. And it also reflected, and you could just put reflected, but specifically over the x-axis. And for us in Algebra 1, that's all it's going to do. When you get to Algebra 2, you will have other reflections because your parabolas will do more than open up or down. So then, specifically, just so that we don't have to plug this next one in our calculator, this negative on the front, that is what caused the reflection. This 3 right here is what caused it to be narrower. And then this positive 3 at the end, or the plus 3, is what caused it to shift up. So if we look at number 2, let's try to do this one without plugging it in our calculator. So first, the 1/4, since the 3 made it narrower, remember if it's less than 1, it is going to make the graph wider. And then if the minus 6 at the end is going to cause the graph to shift down. Notice there's not a negative in front of the 1/4, so there will not be a reflection in number 2. Okay, here's another great summary of the things that we've learned, because so far we only know that our graphs can get more narrow or wider, or it can shift up or down, and it can also reflect across the x-axis. Okay, next thing we're going to talk about, so we've talked about going up or down, getting narrower or wider, but now we're going to talk about shifting left or right. So notice up here at the top, you have your parent function in blue, and then the green graph is if it's a horizontal shift to the left, and the red is if it's a horizontal shift to the right. Now the easiest way to do this, we're going to go down here to our 2 examples, and notice we don't have any A in front, so there's no more narrow or wider, and there's nothing at the end, so right now we're focusing on our shifts. Now the hard thing about this is that if this is a negative or minus 2 in the middle, normally we think to ourselves, well, that's going to go to the left, but the horizontal shifts are actually the opposite direction from what we think. So a minus 2 inside of your parentheses, meaning that that is going to shift to the right. So it's backwards from what you probably think. Then if you have a plus 1, inside your parentheses, so that's very important, then that is going to shift left. So whenever you're talking about your inside your parentheses, you have to think the opposite of what you actually see, which is different because over here, whenever we were plus 3 at the end, notice that 3 is not in the parentheses, you were shifting up. If it was a minus, you were shifting down. If the plus or minus is inside the parentheses, so it's happening to the actual x in the parentheses, it's backwards from what we think. So here, this plus 2 really means that it's going to shift to the left 2. This minus 3 means that it is going to shift right to 3. Okay, so now let's see if we can do these. And remember, you can do these in your calculator. You can leave your parent function in y1 and then graph these in y2. But it's much easier to actually memorize them and graph and just do them without your calculator. So we know this plus 2 at the end is going to shift our graph up, and then specifically 2 units. You don't have to put the 2, you just need to know that it shifts up. Then this minus 3, since it's inside our parentheses, is going to shift to the right 3 units. If you want to check that, we'll check this first one. So I'm going to graph that in y2. So I've got parentheses x minus 3 plus 2. I'm going to press graph. So the first one's going to be my parent. The second one should be shifted to the right 3 spots and shifted up 2. So shifted 1, 2, 3 to the right and then up 2, and that's exactly where my vertex is. So now let's look at B. So we have a plus 4 inside of our parentheses. So that actually means that it's going to shift left 4 spots. The minus 1 at the end means that it is going to shift down. Go ahead and pause the video and try to do A and B on your own. So here we have a plus 2 inside our parentheses. So plus 2, because remember the ones inside the parentheses are backwards from what we would think. It's going to shift left 2 units. The plus 3 at the end means that we are going to shift up 3 units. You can always plug these in your calculator to double check yourself if you want to try by hand. So this minus 1 inside the parentheses means that we are going to shift to the right 1. This plus 4 at the end means that we are going to shift up 4 units. Okay, so here's a great summary of everything that we've done so far. So remember, you can have the vertical shrinks or stretches, which is the wider or more narrow, the shifting left or right, and the shifting up and down. You can have all 3 of those in one equation. Next thing we're going to learn is we're going to look at vertex form. So far with quadratics, we only know standard form, but now we're also going to learn vertex form, which is at the top of this page, right here. And one thing about vertex form that you need to know is that the vertex, which we know how to find in our calculator now, is at h, comma, k. So h is right here, k is at the end. And you'll notice that this form should look very familiar based on our transformations that we just did, because our transformations are easiest to see when our equations are in vertex form. So use the description to write a quadratic function in vertex form. So the parent function, and it actually gives it to us, but remember that's something that you need to memorize, is vertically compressed by a factor of 1/3 and then translated 2 units to the right and 4 units down to create the new function g. So we need to, and notice here, you have a fill in the blank that you normally will not have. But this is vertex form, because remember, there's what vertex form looks like at the top. So you're filling in everything that you need to for your translation. So remember, vertically compressed, and I think I called that shrinks and stretches. So that would be this would make it wider. So that would be a shrink. It is going to affect your A value. It is going to affect your A value. So I'm going to plug that in vertex form for the A. Then translated 2 units to the right. That is going to affect, if we look back up here, oops, wrong way. That is going to affect your H value right here inside your parentheses. Now remember, and this is one that you have to think about, if it's 2 units to the right, so I would go to the right, whenever we would write that, and I'm just going to write it, 2 units to the right would be x minus 2 squared in vertex form. So that means if it's to the right, I'm just going to plug in that number. And then 4 units down, so that's going to affect your K or our C. I'm going to show you. Remember, this right here, before we called it our C, but now in vertex form it's called our K, but it's the same thing. So 4 units down, so we need to make sure that even though there's a plus right there, that's a minus 4. Now I'm going to rewrite this just to make it look nice. We have g of x equals 1/3 times x minus 2 squared minus 4. Remember, the 1/3 makes it narrower. This minus 2 shifts right. And this minus 4 at the end shifts down. Okay, now we are going to write an equation in vertex form given a couple of points. So notice I put the vertex form at the top for you, and it is on your EOC chart. Make sure you're using the most up-to-date EOC chart. Write a quadratic function in vertex form and standard form that contains the point 3, 6 and vertex 2, 8. So in this case, whenever we go to write this, we have f of x equals, now I don't know what my A is right here, so I'm just going to put A, then parentheses x minus, and remember your vertex is h, k, so that 2 is going to be my h, squared, and then plus 4. Now, as I'm looking at this, we have one problem. We don't know what our A value is. To find our A value, that's why you must have this other point, because we're going to have to go do some more side work so that we can figure out what this A value is. So, here's my side work over here. You are going to plug in the exact same thing that you just did right here. The only difference is you have to plug in this x and y from the point that you were given. This is going to be where you plug in your y. This is going to be where you plug in your x. Notice whenever you do that, you are then going to be able to solve for A to plug in to get your final vertex form. So now, and here's my side work, I'm going to have 6 equals A times x, instead of an x, I'm going to write a 3, minus 2 squared plus 4. Now I just have to solve for A. So 3 minus 2, 6 equals A times 1 squared plus 4. So I know 1 squared is just 1, so 6 equals A plus 4. When we solve, we're going to end up with A equals 2. So I'm going to come back over here and I'm going to rewrite this. F of x equals 2 times x minus 2 squared plus 4. This is vertex form. Okay, last thing we're going to do is we're going to take this vertex form and convert it to standard form, which for us, what that means is we're going to simplify this side over here, and when we do that, we should have standard form. Now, I've got a little bit more scratch work to do, because first thing we need to do is expand x minus 2 quantity squared. So hopefully you'll remember that we just have to write that twice, x times x minus 2 times x minus 2, and we have to double distribute or factor. So when I double distribute, x squared minus 2x minus 2x plus 4. So everything inside that parentheses is going to turn to x squared minus 4x plus 4. So my next step will be to rewrite with that. So 2 times x squared minus 4x plus 4 at the end. Then we need to distribute that 2. So we have f of x equals 2x squared minus 8x plus 8. Then now we don't need our parentheses anymore, so I'm just going to add 4. And your very last step is going to be combine your constants at the ends. F of x equals 2x squared minus 8x plus 12. This down here is standard form. Okay, I'm going to do one more of these together, and then the next two I'll just write the answers for you to check to make sure that you're getting them correct. So first thing, you have your vertex and you have your point. So for my vertex, I always label HK just so I don't forget, and this is XY if you want to label it. Now that you know you're going to have to solve for your A value first, that might be the best thing to start with. It's really up to you as far as you want to, because whenever we find our A value, you have to plug in everything. Also remember, make sure you have your chart so that you can find that vertex form. So you don't have to, you should memorize it by the end, but right now you can definitely use it. So, oops, I almost started to write f of x, but remember, instead of f of x, you're going to write your y. So that's negative 5 equals, we don't know our a, that's what we're trying to find, and then we have x, which is 3, minus our h, which is 5, squared, and then plus our k value. So really, instead of a plus, I'm going to put a minus 1. So that's negative 5 equals a times negative 2 squared minus 1. Remember, if you square a negative inside of parentheses, it's really a positive. So we have negative 5 equals, that's going to be 4a minus 1. So I'm going to plus 1. Negative 4 equals 4a. So a equals negative 1. Now we can go ahead and plug into vertex form. So we have f of x, which remember is just really y, equals negative. You can put the 1 if you want to, but you don't have to. Parentheses, x minus h squared. Then it's going to be plus k, but since k is negative, I'm just going to put a minus 1. Next thing we need to do is go to standard form. Remember, this is vertex form. So we need to go to standard form, and to do that, you just have to expand this. So I'm going to do that over here on the side. So I have x minus 5 times x minus 5, so that's x squared, minus 5x minus 5x, plus 25, combine like terms, so x squared minus 10x plus 25. So I'm going to replace that with what's inside my parentheses. So we have f of x equals negative x squared minus 10x plus 25 minus 1. Next thing, we need to do two things. We have to distribute this negative. So f of x equals negative x squared plus 10x minus 25, and then I still have my minus 1. Very last step, I have to put together or combine these two constants. Y equals negative x squared plus 10x minus 26. You may want to pause the video at this point and try to do 2 and 3, and then the answers will be there whenever you start the video again. Okay, so there's your answers. I want to say a couple of things. For instance, on vertex form on number 2, you do not have to include that minus 0. So technically, you don't even have to have your parentheses. So keep that in mind. And then and also for your standard forms on both of them. It's a kind of big deal in the math world that technically they're saying that we can have fractions in standard form now. But my big thing is I want you to make sure you know how to write it without fractions if you need to. Then the most important thing is that if it's a standardized test, PSAT, EOC, that you recognize that these two things right here, these two equations are the same thing. Same thing over here for those two. They are the exact same thing. Please make sure you come to tutorials if you have any questions.